Hi, I'm Chef T. Today we're going to be talking about solubility and dilution. Solubility is the property of a solute that dissolves in a solvent to form a homogeneous solution. There are three components that affect solubility: pressure, temperature, and polarity. First, we're going to be discussing pressure. To begin, a change in pressure has very little effect on the solubilities of liquids or solids in liquid solvents. However, an increase in pressure increases the gas solubility in a liquid. When a gas comes in contact with the surface of a liquid, gas molecules enter the liquid. So as our example, we decided to use water and a straw to show this theory. Elena's going to come over and explain how it's done.
I'm going to blow air through the straw into the water and create bubbles, which is a gas exchange.
Yay. To further explain, when Elena blew through the straw, there was an increase in pressure which caused oxygen bubbles to occur inside the water. The next component that affects solubility is polarity. For example, two nonpolar molecules mixed with other nonpolar molecules, and the same with polar molecules mixing together. Just think, like dissolves like.
Now we're going to have Morgan come up and help me demonstrate this solution. She's going to take water, a polar substance, and mix it with oil, a nonpolar substance, and see what happens. As you can see, this substance is insoluble because neither of the liquids are mixing together. They remain separate.
The last component that affects solubility is temperature. For example, when you have a gas, when the temperature increases, the solubility decreases. This is because there are less gas molecules present, which makes it harder to dissolve. However, the opposite occurs when you have a solid. If you have a solid, when the temperature increases, the solubility also increases. Today, as our example, we're going to have salt dissolve in water. However, the difference is we have boiling hot water over here and room temperature over here. The water in this glass will dissolve slower than the water in this glass. So to start, we'll show how the solubility is, how the water is less soluble in this glass. As you mix it, some of the salt does still dissolve, but there are still particles stuck on the bottom of the glass. Okay, now we have boiling hot water. And as you can see, in a matter of seconds, all of the water dissolves the salt.
The final topic we'll be discussing is dilution. Dilution is not a component of solubility, but it's very similar. Dilution is the process of adding more solvent to a solution. The number of moles of the solute stays the same, but when water is added, it increases the volume and decreases the molarity. So here we have 2 cups of water with the same amount of drink powder mix in them. And I'm just going to add water to one of the cups, which, as you can see, dilutes it, and it makes it less concentrated. Now we're going to show you how to solve a dilution word problem. The problem is, what volume of a 16 mole of sulfuric acid must be used to prepare 1.5 liters of a 0.10 mole of H2SO4 solution? In the equation, M equals molarity and V equals volume. In this problem, the initial molarity is 16 moles per liter, and the initial volume is unknown. The final molarity is 0.10 moles per liter, and the final volume is 1.5 liters. The equation to solve it is M1 times V1 over M1 equals M2 times V2 over M1, or V1 equals M2 V2 over M1. This is equal to 9.4 milliliters. So, to make 1.5 liters of 0.10 moles of H2SO4 using 16 moles of H2SO4, we must take 9.4 milliliters of the concentrated acid and dilute it with water to a final volume of 1.5 liters.
What am I supposed to start off with?
Oh, right.
To begin, change in pressure has very little. The next topic we're going to use is okay, like, for example, if we took two nonpolar molecules, that's wrong. It's a polar and a nonpolar.